Welcome DKWP Xiaogong aboard. Your learning journey starts now. Ever felt like information is just floating around, separate from the physical world? Think again. We're diving into a cosmic connection, how information and energy might be two sides of the same coin. Forget E equals mc squared for a second. Could there be an ultimate mapping, maybe even a constant, linking bits and joules? Let's start with the basics. So, how do we even begin to connect these seemingly different worlds? Enter entropy. Shannon's information entropy, measuring uncertainty in messages, looks suspiciously like Gibbs' physical entropy, measuring disorder in systems. It's like they're twins separated at birth. Von Neumann cheekily told Shannon to use entropy because no one really understands it. He was right. This mathematical similarity is our first clue. Then comes Maxwell's demon, a tiny gatekeeper sorting fast and slow molecules, seemingly creating order from chaos, violating the second law? Not quite. The catch? The demon needs memory, and erasing that memory costs energy. Landauer's principle nails it down. Erasing one bit of information releases at least kBTLN, 2 joules of heat. Information isn't free. It has a physical price tag tied directly to entropy and temperature. This is the bridge. Okay, so we know information and energy are linked via entropy. But what about meaning? What about purpose? Maxwell's demon had a goal: create a temperature difference. A system with no goal, even with tons of data, struggles to turn information into useful work. So, we introduce purpose. Think of it as the third vertex in our triangle. We get this cool idea: information acts on energy to achieve a goal, and the outcome feeds back, influencing future information processing. This leads to concepts like informational potential. How much potential does a piece of info have to help achieve a specific goal? And intentional entropy, the uncertainty or dissatisfaction related to the goal itself. We even throw out a conceptual formula linking changes in free energy to changes in both information entropy and this intention-driven entropy. It suggests purposeful information processing can be way more efficient. Now, let's zoom out. If information and energy are fundamental, what about consciousness? We propose a consciousness field. Think of it as a special kind of information structure embedded in the flow of energy, constantly influencing itself. Like integrated information theories phi, but explicitly tied to energy dynamics. And how did we get here? Through symbol evolution. From raw energy signals like light hitting your eye, to encoding them as nerve impulses, then compressing that into meaning like recognizing an apple, and finally, boiling it down into symbols like the word apple. Each step refines information and makes energy use more efficient. This whole process, from physical energy to symbolic thought, perfectly illustrates our IIE triad: information guiding energy, driven by purpose, all interconnected. So, we have the pieces: information, energy, purpose. How do we put them together formally? We dream up a unified structure tensor. Let's call it J sub AB. Imagine a mathematical object that simultaneously describes energy density, information entropy, semantic coupling, and how they all interact across space, time, and maybe even higher dimensions. It's ambitious. To visualize this, we create an information energy unified atlas, showing how information flows from the physical world, gets processed, and drives actions, all guided by purpose. This isn't just theory. It has practical implications. For AI, it suggests designing prompt templates that explicitly ask models to consider energy costs and ultimate goals, moving beyond just information processing. It's about building smarter, more balanced, and ultimately, more unified systems.